doing part E of the homework. So it's ln xy that we have to derive. So we're going to first apply the formula ln fx, which is 1 upon fx times f prime x. So it's going to be 1 upon fx is xy here times, now we derivate xy. Now xy is an implicit equation. Also, it is a product. So we will use the product rule of differentiation, which is if we're multiplying fx and if we're derivating fx and gx, so that would be f prime x times gx plus fx times g prime x. So I'm going to multiply the derivative of x first, which is just 1. And you may write dx over dx with it, or you may not. That's fine. And then y with it times y plus x as it is. And we derivate y with respect to x. So it's dy over dx. So that is the derivative of ln xy. So it's going to be 1 over xy, y plus x dy over dx. And if you expand this further, if you expand this bracket, you will get this. Because in the first term is y, cancels with the y in the denominator, so you get 1 over x. Plus the second term is x. When you multiply 1 over xy with it, x's get cancelled and you get 1 over y dy over dx. So that's how you get that. What were you doing wrong?
I did it right, but I couldn't get the final term. मैंने 1 over xy y plus x dy over dx कर दिया था.
Okay, okay. ठीक है. चलो. Okay, maybe the others are not going to show up today, so let's just move on. Give me 2 seconds. So we are going to continue with the implicit equations. Find the equation of the normal to the curve. Two x y square plus x square y cube equals to 1 at 1, 1. Equation of normal. So what's the difference between equation of tangent and equation of normal? For equation of tangent, you just find dy over dx and then substitute x equals 1 in it and you get a slope. So that's your m for the equation of the tangent. But in equation of normal, you have to take negative reciprocal of that value that you get first. And then use y is equals to mx plus c. Okay? Find a slope using dy over dx, but that slope is the equation, is the slope for the tangent. For the normal, you have to take the negative reciprocal of that. Just a second. My stylus got stuck in my hair and it looks like it's broken, but no, thank God. Right. Derivate this And it's an implicit equation, so it's going to be slightly more challenging. Plus their products here and here. So we'll have to use product rule as well. So 2 is a coefficient, 2 is 2. Derivative of xy square. So we're using the product rule. So derivative of x is 1. You may write dx over dx. I'm not going to do it this time. And then y square gets multiplied with it. And then we have to multiply, write a plus sign. X is as it is. And now we derivate y square in term with respect to x. So it's going to be 2y dy over dx. So far, we've only derivated that purple expression. Plus, now we derivate this. Again, product rule. So x square's derivative is 2x dx over dx, which I'm not writing, times y cube plus x square, derivate y cube with respect to x. It's going to be 3y square and then dy over dx. Bracket close equals derivative of 1 is 0. So simplify, we get 2y square plus 4xy dy by dx plus 2xy cube plus 3x square y square dy over dx equals to 0. Okay. So take dy over dx common and also move the all the non-dy over dx terms to the right. So I'm going to do that first. So I get minus 2y square minus 2xy cube and take dy over dx common here. And we get 4xy plus 3x square y square. So dy over dx equals minus 2y square minus 2xy cube upon 4xy plus 3x square y square. Now to find the slope of the tangent, I'm going to write mt. The slope of the tangent, you substitute the given values of x and y, which are 1, substitute 1, 1 here and give me the slope of the tangent.
Minus 4 over 7.
Something has gone wrong. dy over dx expression is not the same as it is at the back of the book. Hold on. What has gone wrong? I think I might have, yes, this was, chalo. Let's just assume this was the equation. And I'm going to substitute 1, 1 here. So minus 2 times 1 square minus 2 times 1 times 1 in the numerator. Denominator is 4 times 1 times 1 plus 3 times 1 times 1. So yes, minus 4 over 7. All right. And then the slope of the normal is going to be negative reciprocal 7 by 4. Okay. Now we're going to use 1, 1 and 7 upon 4 to find the equation of the normal. I'm going to use this format, y minus y1 is equals to mx minus x1, so that I don't waste time finding c. So point is 1, 1, slope is 7 over 4. So y minus 1 equals 7 by 4 x minus 1. That's going to be the equation of the norm. And had they just asked for the equation of the tangent, then it would have been y minus 1 equals minus 4 over 7 x minus 1. This is equation of the tangent. Question 2. Find the coordinates of the point on the curve where tangent is parallel to x-axis. Find the coordinates of the point on the curve where tangent is parallel to the x-axis. And the curve is four x square plus 2xy minus 3y square equals 39. All right, derivate this. It's an implicit equation. So 4 times 2x times dx over dx, which I'm choosing not to write, plus 2 times product rule, which is derivative of x is 1 times y plus x times derivative of y, which is dy over dx, minus 3 times 2 times y times dy over dx equals derivative of a constant is 0. So 8x plus 2y plus 2x dy over dx minus 6y dy over dx equals 0. Moving the non-dx dy terms to the other side, minus 8x minus 2y, take dy over dx common, 2x minus 6y. How long I've been on mute?
No, I could hear you.
अच्छा अच्छा ठीक है. Okay, so dy over dx equals minus 8x minus 2y upon 2x minus 6y. Okay, take 2 common from the numerator and denominator and simplify this. So that's going to be minus 4x minus y over x minus 3y. Let me check if this is correct. Yes, it is correct. Okay, so that's the expression for dy over dx. Minus 4x minus y upon x minus 3y. Okay, now it says find the coordinates of the point on the curve where the tangent is parallel to the x-axis. I'm just going to draw a random curve draw a tangent that is parallel to the x-axis. So this is what the tangent would look like when it's parallel to the x-axis. So what is its slope here? The slope is 0. Yes, it's 0. That means dy over dx should be equals to 0. If it has a tangent that is parallel to the x-axis. So for dy over dx has to be 0, right? So dy over dx is minus 4x minus y upon x minus 3y equals 0. So the denominator just gets eliminated. So we have minus 4x minus y is equals to 0. So we have y equals 4x. No, y equals minus 4x. All right. Now we still need the coordinates. So we need two values of, we need a point x comma y where the tangent is parallel to the x-axis. So we know that y is equals to minus 4x. Do what? Substitute it back in the given equation and then get values of x from there or a value of x from there. So y is equals to minus 4x. Put it in the original equation. We have 4x square plus 2x. Y would be minus 4x minus 3. Y square would be minus 4x whole square equals 39. Okay. So we have 4x square minus 8x square. That's going to be minus because minus 3 times, that's going to be positive 16. Minus 3 times positive 16 is minus 48 x square minus 39 equals to 0. So what are we getting? 4 minus 8 minus 48 is minus 52x square equals 39. X square equals 39 over minus 52. कोई बहुत बड़ी गलती हुई है. Let me check. What kind of an answer is this? Y is minus 4x. Y does come out to be minus 4x. Put it back, 4x square plus 2x. Y gets replaced with minus 4x. So that's minus 8x square. Then minus 3 y squared. So minus 4x whole square equals 39. It's looking fine. So 4x square minus 8x square, 4 minus 8 minus 48 is minus 52.
If we simplify the fraction, we get minus 3 over 4.
But we cannot square root. We cannot square root a negative value. ना इसलिए मुझे समझ आ रहा कि what went wrong. Shouldn't be negative. Should be positive. Let me check the answer. The answer for this is, oh, it says the answer is not possible. So yes, we're not getting an answer. X squared equals negative, what was that? 3 over 4?
Yes.
So no solution. We can't square root a negative number. Okay? So there's no point on the curve where the curve is parallel to the tangent. It's parallel to the x-axis. So there is no point on this curve where tangent is parallel to the x-axis. Let me know when you're done.
I'm done.
All right. Let's change the question. I'm not sure if we'll still get an answer or not, but I want you to have this in mind as well. That sometimes the question would say, find the coordinates of the point on the curve where the tangent is parallel to the y-axis. So how does the question change if it says parallel to the y-axis instead? If it says y-axis, parallel to the y-axis. Okay. So can you rewrite the question? Find the coordinates of the, don't write the entire question. Just make it clear that now the question is the same, but it has to be parallel to the y-axis. Okay. So if it is parallel to the y-axis, then this is what the curve might look like. It would be a curve like this, and a point on the curve would have a tangent drawn on it, which would be parallel to the y-axis. What's the slope of such a line, a vertical line? Remember the
Zero.
face? No, that's for a flat line. Remember this face? This is a positive gradient, this is a negative gradient, that's a zero gradient, and this is an undefined gradient.
Infinity.
Yes, undefined gradient. And when do we get undefined in the calculator? In the calculator, undefined is represented by math error. Math error kab aata hai? When the denominator is zero. So for this dy over dx, if the tangent is parallel to the the y-axis, then its denominator must be zero. So x minus 3y should be equals to 0. That means x equals 3y. Now let's try to substitute it in the original equation. Maybe this time we'll get answers. Not sure though, since I just made the question up. Maybe ये भी ना exist करता हो. Let's see. Okay. So replace the x with 3y. So 4 times 3y squared plus 2 times 3y, that's, yeah, 3y times y minus 3y squared equals 39. So we have 9 times 4, 36y squared plus 6y squared minus 3y squared equals 39. This will hopefully give us an answer. 4 times 9, 36 plus 2 times 3 minus 3 is 39. So getting 39y squared equals 39. So y squared equals 1. So y equals plus minus 1. Okay. So if y is plus minus 1, y is 1 or y is minus 1, then x would be 3y. So x is 3 here and x is minus 3. So we have two sets of points where the tangents would be parallel to the y-axis. So one of the answers is 3, 1 and the other answer is minus 3, 1. Any questions, Mary?
No, ma'am.
Okay. Let me just quickly recap this. So when the tangent is parallel to the x-axis, tangent parallel to x-axis, the slope is 0. The gradient is 0. That means you just equate dy over dx to 0. But when tangent is parallel to the y-axis, then the curve may look like this. The slope is undefined. Now this would mean that the dy over dx that you have in terms of fraction, only the denominator should be equals to 0. Understood?
Yes, ma'am.
Acha. One last thing. Instead of saying tangent is parallel to the x-axis, instead of saying this, the question might say this: normal is parallel to the y-axis. It means exactly the same thing. When normal is this line, normal is parallel to the y-axis, that means the tangent is parallel to the x-axis. And that means dy over dx is 0. So instead of the question saying that the tangent is parallel to the x-axis, the question might say normal is parallel to the y-axis. And you must know that this translates to tangent is parallel to the x-axis, which translates to dy over dx equals to 0. Okay. Similarly, instead of saying tangent is parallel to the y-axis, the question might say normal parallel to x-axis, which is this. Normal is a line perpendicular to the tangent. So look at the figure. The normal is parallel to the x-axis. That means that the tangent is parallel to the y-axis. That means the denominator of dy over dx is. So maybe the question mentions tangent, maybe the question mentions normal. If the question mentions normal, so फिर translate it to what it implies about the tangent. And then see if dy over dx is 0 or the denominator of dy over dx is 0. Okay? Okay, next we have to start the worksheet, but I suggest let's do it on Monday. Okay?
Okay, ma'am.
Take care. Allah Hafiz, Marine. Have a good weekend.
You too. Love.